Hi everyone, my name is Ayemi Hamzat. I'm a computer science major, Fisk University from Lagos, Nigeria. And today I'm here to present my machine learning project based on our prediction of stroke through, some various variables I got from my data sets. Some of those variables included the BMI ratio, blood sugar level, the glucose level, the blood pressure level of those participants that were used in the survey for the data. Moving on to the next slide, stroke here. I'm going to be introducing stroke here now. Stands as one of the leading causes of disability and mortality here. Its impact is profound, touching lives and communities. Early detection and prevention are key, yet they remain a challenge worldwide and globally. This is where my project steps in, right? The goal of my research is to enhance stroke prediction through using a large range of machine learning techniques. By analyzing healthcare data, I aim to identify the patterns, and indicators that could signal the risk of stroke before it occurs. So my data basically all started with data preprocessing, cleaning, and sorry. Yeah, it also started with data preprocessing, the cleaning and standardizing data, followed by the k-means and hierarchical clustering to identify patterns and groups. Next, I also delved into regression and cross-validation. This comprehensive approach also set the stage for accurate stroke risk prediction. Trying on slide 4 in data processing, I focused on cleaning and preparing our data sets. A crucial foundation, that's the most crucial foundation before you start, any machine learning algorithm is to clean your data and make sure it's as effective as you want it to be. The crucial foundation, on accurate analysis. Key steps included addressing missing values, the NAM values in my data sets, and also using select K based and select K from model for feature selection, all standardized to ensure uniformity across our machine learning training models. So, social analysis brought up patterns within the patient data risk. Within the patterns within patient data, k-means clustering segmented the data into distant, groups, while hierarchical clustering offered deeper connections, providing a multi-dimensional view of stroke risk factors. In regression modeling, linear regression, or rather, in our regression modeling in slide 6, linear regression is our set our baseline, while supports vector regression, was the second regression algorithm I used for my project. Then random forest regression also tackled more complex data relations, like how the relationship between the BMI and the high the blood pressure level of the patients using data sets, relates and enhanced our prediction ability. In slide 7, I went to my classification algorithm. Classification algorithms were also pivotal. Each model from the decision tree to the SVA model provided unique insights crucial for predicting stroke events accurately. I did the KNN, I did the naive-based classification, also the random forest classification, and the decision tree classification as my classification methods in my project. The project can also be found in the comment section of this video when I'm done with the presentation, so you guys can look through the codes, my values, my accuracy values, my recall values, and for all the various classification models and regression models. So basically, our models underwent rigorous evaluation, like accurate precision recall and ROC and AEC curves were key in assessing the performance of my my models and classification models, like my regression models also. With cross-validation confirming that consistency and reliability. I did some cross-validation also to see the consistency between my various models, to see how they are related to one another. Our results are very revealing. The clustering showed the risk groups. The regression models highlighted some significant risk factors, and classification models confirmed the high accuracy, and especially with the random forest classifier. Yeah, I think that was one of my best classifications. It showed, if you look at the code after this video, you can look at the code, you see that my random forest classifier says a lot about the accuracy of my data. To conclude this project, not only demonstrate basically this period not only demonstrates the efficiency of machine learning in stroke prediction, but also opens up possibilities of its application in personalized healthcare and early detection stage. So basically, it helps to know how to detect or the expectancy of, or not really expectancy, but how prone you are to exposure to stroke based on some things you possess, like your BMI level, your sugar level. There's some things you have to control to reduce the risk of having stroke in the nearest future. So this is my ROC curve for basically, and my heat map also, my performance metrics heat map for my, this is the results. You could also see it also in the PY, IPY file I'll be in the comment section of this video. And finally, while acknowledging the data sets limitations and the need for further modeling, this is my conclusion, demonstrated the effectiveness of machine learning, improving the risk prediction through various models and techniques. I uncover significant health indicators and crucial or critical predictors of stroke risk, highlighting the potential for targeted healthcare interventions. I also recommended further exploration into more sophisticated, models that I can use for my data set. So those are conclusions I came about from the project. So now the limitations, while acknowledging my data limitations and the need for further modern testing or future testing, directions are also promising. The directions from my project is promising. Expanding data sets, integrating these models into a clinical practice is something I wish for in the future, to meet various clinical practitioners. So show them basically what my algorithm talks about and how it could help in the healthcare system, and exploring advanced techniques like deep learning are the next steps for my project. So yeah, so thank you guys very much for viewing my project. And if you have any questions, my contact information will be below in the comment section. I have take more time to explain basically my code to you. Thank you.